All right, so today we're talking special right triangles. This is going to build off of yesterday when we talked about the Pythagorean theorem. Um, so there are two main special right triangles, and that's 45, 45, 90 triangles and 30, 60, 90 triangles. Um, so the I can statements today are that I can use the properties of 40, 40, 90 triangles and 30, 60, 90 triangles. So there's a couple different theorems today, and they really revolve around the measurements of the side lengths in these two types of triangles, your 45, 45, 90 isosceles triangles and your 30, 60, 90 scalene triangles. So the first one we're going to talk about today is the isosceles 45, 45, 90 triangle. And so essentially, anytime you have in a 45, 45, 90 triangle, the legs L are congruent, which we've talked about before. If the angle measures 45 and 45 are the same, then the opposite side lengths must also be the same. And so the legs are congruent, and then the length of the hypotenuse is square root 2 times the length of a leg. So the good news is, if we have one side of a 45, 45, 90 triangle, then we can find the length of every single side. The bad news is that involves a root 2, which makes for some messy decimals from time to time. So in my notes, what I would make sure I had written down was for a 45, 45, 90 triangle, it is always going to be some sort of variation of this. Side length, those are congruent, and then we have the side length times root 2. So for example, if we had anything that looked remotely close to a isosceles triangle, so if we had something like this, where this was our 90-degree angle, and let's just say these side lengths were 2. So this one would be 2, this one would be 2, and then this final side length would be 2 root 2. So, long story short, depending on the side length, we can always just multiply across the board by the same number or the same factor and figure out all our side lengths. So an example of this being, in this problem, they ask us to find x. Well, they show we have 145-degree angle, a 90-degree angle, which means we know that this third angle is 45. So we have a 45, 45, 90 triangle, which means the two legs of the triangle are going to be the same. So we're going to have 9, 9, and then unknown for x. Well, if we look back to our rule, we know our hypotenuse, which is x in this case, we can sum up as one of the legs, which is 9, times root 2. So 9 root 2 is going to be our x value. So we would say x equals 9 root 2. And that would be that. That's all there is to it. What I would make sure I have in my notes for certain, though, is an image of this triangle right here. And I'd make sure I labeled it 45, 45, 90, just so I have that to look back on always. So in this case, we're trying to find x again. And so we have So in this case, we have a 90-degree angle, and then we have two sides that are the same length, which tells us that these two angles must both be 45, because they must be congruent if the two side lengths are the same. So in this case, we have a side length of 6 root 2. And we know the side length times, let's make that a separate line here. So we know side length, which in this case was 6 root 2, times root 2 is going to equal our hypotenuse. So, did I delete that? Am I losing my mind? Oh, no, I didn't. I'm sorry. confusion. There we go. So if we did 6 root 2 times root 2, we would get 12. Because root 2 times root 2 would just be 2, and then 6 times 2 would be 12. So it would be x equals 12. That's pretty much all there is to these 45, 45, 90 triangles. So once again, we have 7, 7, 7 root 2, 8 root 2, 8 root 2, unknown. So 8 root 2 times root 2 is going to be 16. And we just continue on with that pattern. So, in my opinion, this is kind of the hardest example of this type of problem. So, we know in our 45, 45, 90 triangles, I'm just going to draw, let's draw it like they have it. So, we have this 45, 45, 90 triangle, length, length, length times root 2. So, in this case, what we're doing is we are taking the hypotenuse, and then we are figuring out exactly what each side length is. So the tough part about this to me is we know A is going to equal so we know 8 equals length root 2. So in this case, I'm going to call this A, since that's the variable they're using in this problem. So what I would need to do is I would need to divide each of these by root 2. So divide by root 2, divide by root 2. Those root 2's cancel, so I know A is going to equal 8 divided by root 2. Now, when it comes to simplifying this, that is what gets a little bit messy. So when we have this 8 root 2, we're going to want to multiply by root 2 over root 2. Because we're just multiplying by 1. You can do that without changing the problem at all. And so by doing that, we would be left with 8 root 2 up top, and then we would be left with 2 down below. And then we could divide this 8 divided by 2 is 4, and so we are left with 4 root 2, which is an absolute mess to get to it mathematically, to be fair. Now, the good news is, if our hypotenuse is something like 5 root 2, well then we know A is going to just be 5. So it's only an issue when our hypotenuse is this whole number. Now, my trick for this, if you notice, so our whole number was 8. 8 divided by 2 is 4, so it's 4 root 2 for each side length. So as a rule of thumb, I would just divide my hypotenuse by 2, times it by root 2, and that would be that as my general rule. Just to save time, but you can work it out longhand mathematically as well. So, in this case, right off the bat, that trick I just told you about. So, my hypotenuse is 6. We can go through all those steps we just did, or we can say 6 divided by 2 is 3. 3 times root 2 is 3 root 2. That's our answer. Just like that. Now, if we did want to go through the long way, we could say, okay, 6 equals B times root 2. We got divide by root 2, which I can't even write right now. Divide by root 2. 6 over root 2 times root 2 over root 2, which is going to be 6 root 2 over 2. And we're going to get to 3 root 2 in the end anyway. Okay? Lovely. So now we get into our 30, 60, 90 triangles. These are a little bit messier, if you will. So, I don't know if I'd say messier necessarily. So once again, I would make sure I draw this lovely picture that they have up top, knowing the following information. So in a 30, 60, 90 triangle, each side length is going to be different, which can make this a challenge. So this angle's 30, this one's 90, this one's 60. So the cool part is, in theirs up here, side AB, or the side opposite 30, is just going to be one side length, or instead of using S, I'll use L, because I feel like L is easier to see than S. S ends up looking like 5. So that's L. And the nice thing about that is the hypotenuse is 2 times L. So right off the bat, 2 of our side lengths should be relatively easy to find. Now, as far as our third one, we have L root 3, which, as we saw last time, can be a challenge. But once again, I would make sure I put this picture into my notes, because it is going to come in handy when you're trying to think back to this. So in this example, they want us to find both X and Y. So important information to note. This is our length. L equals 4 root 3 over 3. We know side QR is opposite 90, so that is 2L. And then we know side PR is L root 3. So what that means for us is, in order to find Y, or side QR, we need to multiply this whole sum by 2. So how that's going to work, we know Y equals 2 times 4 root 3 over 2. Lovely. Sorry, over 3. I lied. So if I were to multiply this in, what I'm going to end up with is Y equals 8 root 3 over 3. So that's my Y value, just like that, right off the bat. Now I need to find my X value, and my X value is going to be this circled quantity again, times root 3, which seems horrible, but it's actually not going to be that bad. I don't believe. Oh yeah, I'm sorry. Losing my thoughts. So L is 4 root 3 over 3, and we need to multiply that times root 3 for X. X equals 4 root 3 over 3 times root 3. Now if we multiplied all these together, I'm just going to relocate this a little bit just to make it a little bit easier to see. So if I have 4 root 3 over 3 times root 3 over 1, and we multiply straight across, we know that root 3 times root 3 is just 3. So we can pretty much just get rid of that square root sign, which leaves us with 4 times 3. 4 times 3 is 12. 12 over 3, which simplifies to 4. So X equals 4. Those are a lot messier in my opinion. However, it's still just plugging values in, using that rule, and solving. So in this example, they give us the side length opposite the 60, and if you remember, side length opposite the 30 is L, hypotenuse is 2L, and then side AC, or the side opposite 60, would be L times root 3. So we have 4 root 3 is the measurement they give us, which means L must be 4. So we know L equals 4, and they want us to find side BC. So 4 times 2 would be 8. Lovely, lovely, lovely. All right, last problem, or second to last problem. So a quilt has the design shown in the figure, in which a square is divided into 8 isosceles right triangles. If the length of one side of the square is 3 inches, what are the dimensions of each triangle? So I just copied this onto another page. So essentially what we have here is we have a 3 by 3 square. So each chunk here would be 1.5 inches. So I'm just going to kind of pull a triangle out here. So we have 1.5 inches, 90-degree angle, 1.5 inches, and then we have unknown, what we're trying to solve for. I'm just going to call that X. Now, what we could do, if we wanted to, do Pythagorean theorem. There's no law against it. However, we know in a 45, 45, 90 triangle that we have L, L, L root 2. So I know that my length for this, the hypotenuse of this triangle is going to be 1.5 root 2. And that would be the length of that hypotenuse. Let me double check. If the length of one side of the square is, yeah. So they want to know the dimensions of one triangle. So we would just say one triangle is 1.5 inches, 1.5 inches, then 1.5 root 2 inches. Just using those special right triangle rules. All right. Shayna designed 2 identical bookends. According to the diagram below, use special triangles to find the height of the bookends. So, first things first. Opposite the 30-degree angle is L. L is 5. Our hypotenuse would be 2L, or 10 in this case. And then our height would be L root 3. L is 5, 5 root 3. Boom.